Good morning, trig students. So this one is Mr. Chen, and today I would like to go over some of the sample problem for the upcoming final for trigonometry. So as you can see that right here, find all the values of the 6 trigonometric functions. So which means it's like sine, cosine, tangent, SOHCAHTOA, and also SOHCAHTOA, which means that the reciprocals of cosine, sine, and tangent. So reciprocals of cosine would be secant, reciprocals of sine would be cosecant, reciprocals of tangent, then that would be cotangent. So first thing that you want to do, so with the given ratio, so you want to find out that the allocation of the right triangle. So this one is in quadrant 4, so it's all the way down here. So according to the ratios of tangent, it's considered opposite over adjacent, so it's -4, opposite, adjacent is 3. Hypotenuse, using the Pythagorean theorem or the Pythagorean triplet, you'll see that hypotenuse would be 5. So theta, it's all the way over here. Again, the one that's being bounded with the terminal psi and the x-axis, so that one is just the reference angle. So in order to get the rest of the ratio, so we are finding cosine of theta, which is considered x over r, or adjacent over hypotenuse, so it's 3 over 5. And then sine of theta, which is y over r, using those formula, or opposite over hypotenuse, which is -4 over 5. And then tangent of theta, which is already given, -4 third. And then finding the rest of those ratios, so secant, which is the reciprocals of 3/5, r over x, so 5 over 3. And then sine, reciprocals of sine would be cosecant, which is r over y, so 5 over -4. And then tangent, reciprocals of that, cotangent, which is considered, this one would be x over y. By the way, tangent, the ratio would be y over x. And then this one here would be 3 over -4. And now let's see, converting that degree to radians, so we do have -144 degree multiplied by pi over 180. So basically this one can cross cancel, so divided by 2 top and the bottom. So this one we'll get -72, this one you'll get 90, divided by 2 again, or perhaps divided by 9. So this one will get -8, this one you'll get 10. So it's -8 pi over 10, and then try to reduce that again, so it's -4 pi over 5. Okay? And now let's see what else that we have right here. So a building casts a shadow, so 12 feet long. Okay, so 12 feet long. So here's the building, cast a shadow, so 12 feet long. If the angles of depression looking down from the top of the building to the tip of the shadow is 50 degrees, so here's the angles of depression, which is 50 degrees. And what's the height of the building? So if this one is 50 degrees, down here it's also 50 degrees, because that the dotted line segment along with this bottom base right here, they consider parallel, so using that geometric theorem. So this one, 2 lines are parallel, that means the alternate interior angle is got to be congruent. So using the ratio to find the height of the building, so tangent of 50, so that equals h over 12. And then what you can do here, cross multiply, so h times 1, that's h, 12 times tangent of 50. And obviously this one you can put into the calculator, or simply just leave it as the way it is. And then the rest of that is pretty straightforward. So find the radius of the circle given that the angles of 1 pi intercepted with the arc length of 9 millimeter. So one thing that we notice, arc length, it's r times theta, where's theta in terms of radius. So the arc length that's given, it's 9 millimeter. And radius, so that's what we need to find out. And we do know that the angle is 1 pi. So basically radius is 9 over pi. Unit, which is millimeter. And find the time it takes to carve out an arc length of 40 meter when the linear speed is 10 meter per day. So linear speed, it's always consider the arc length divided by the time. Okay, so this one, so one thing that we notice, it's already given with that the linear speed, which is 10 meter per day. And then arc length, it's also given, so it's 40 meter divided by the time, so 40 divided by 10, so t equals 4. So then that'd be 4 days. So a fan with 26 inches blade rotates at 6 RPM. Find the angular speed. So the way to find out the angular speed, it's always W equals, let's see, it's, well, W equals normally it's considered theta divided by the time. And also angular speed can be founded by using RPM times 2 pi. So 6 revolutions per minute. So 1 revolution is considered 2 pi. So you multiply by 2 pi radian over 1 rev. So 6 times 2 pi, 12 pi. So the rev got cancelled. So we got 12 pi radian per minute. Okay. And the other one is about finding the triangle. So this one looks like it's given with that the psi angle. So this one using the law of sine to find out what that is. So it's always like sine of A over A, little a, equals sine of capital B over little b. And so that equals sine of capital C over little c. So find the solution of this one. So this one is psi using the law of cosine. So law of cosine is c squared equals a squared plus b squared minus 2ab times cosine of capital C. This one's supposed to be lowercase because that's the segment. So little c squared. So that equals this whole thing. And then the other one, find the area find the area of a triangle. So when d equals 12, e equals 31, f equals 27. So using the Heron's formula, so that means its area equals square root of s, which is the semi-perimeter of the triangle. So s can be founded by using a plus b plus c over 2. So s times s minus a, s minus b, and then s minus c. And then the product of this whole quantity, take the square root. So the Heron's formula. And then the rest of this, so tangent is 1/5. What's cotangent of theta? Well, that's just the reciprocals of that. So then that'd be what? 5. It's pretty straightforward. Pythagorean identity, cosine square of theta plus sine square of theta. So that would be what? 1. And then this one using the sum of sine. So this one, well, the difference of sine. So sine of 72 minus 12. Because the structure for the sum of sine is sine of alpha cosine of beta minus cosine of alpha times sine of beta. So that equals sine of alpha minus beta. So we're using the structure. So that's sine of 60 degrees. So sine of 60 is root 3 over 2 using the special right triangle. And this one, 2 tangent of negative 7 pi over 8 divided by 1 minus tangent square of negative 7 pi over 8. So this one is a double angle. Identity of tangent. So tangent of 2 times negative 7 pi over 8. So tangent, it's a negative, well, it's an odd function. So we're taking out the negative. So negative tangent of 2 goes into 8 4 times. So 7 pi over 4. So negative tangent of 7 pi over 4, which is what? Negative 1. So then that'll be positive 1 here. And then half angle identity. So for cosine of theta over 2. So this one is always considered plus minus square root of 1 minus cosine of theta over 2. And then this one, solving for the secant. So this one is a half angle, so you want to line up everything together. So let theta over 2 equals alpha. So secant cube of alpha minus secant of alpha. Bring everything together. Set that equal to 0. Take out secant of alpha times secant square of alpha minus 1. So you have to factor a little bit. And then this one turns out to be secant of alpha equals 0. And secant square of alpha minus 1 equals 0. So solve for alpha. So this one, if this one is right between negative pi and pi, so that means alpha going to be negative pi over 2. And then the other one would be positive pi over 2. But don't forget about that. This one, you're going from negative pi to pi. Yeah, that's about it. So it's a half angle. We're going to substitute. And then the other one is secant square of alpha equals 1. So that means secant of alpha equals plus minus 1. So we do know that cannot be negative pi. So that means alpha, it could be either 0 and pi. And then once you substitute, so we do know that alpha equals theta over 2. So solve for theta. So that means theta is 2 alpha. So unplug that, multiply everything by 2. So this one we got negative pi, which is not included, so it's not part of the solution. This one multiplied by 2, so we do have alpha equals pi. And this one multiplied by 2, we got theta equals 0. Multiply by 2, so 2 pi, but that's not part of the solution. So it looks like this one is only considered 0 and pi. And then the rest of that is just like factoring, solve for theta. Again, using the same strategy, but if this one is 3 theta, so that means we have to go around the unit circle 3 consecutive times. So besides getting the angle in those quadrants, first, second, third, fourth quadrant, so you have to go around that all the way to 4 pi, all the way to 6 pi. And then whatever that you have for that for the substitution variable, and you need to unsubstitute that by dividing 3. So this one, inverse of tangent of negative 24 over 7. So we do know that this one, inverse of tangent, is bounded in between negative pi over 2 to pi over 2. So negative, it's all the way down here. So using the ratio, negative 24, opposite over adjacent. And then this one is just saying that tangent of theta. Okay. But the thing is that, let's say that it's considered, got to be careful with this one. This one is tangent of, you can say that this one is negative theta, because that it's a negative angle. The restricted value for that inverse of tangent is being bounded from negative pi over 2 to pi over 2. So this one I would say that is tangent of negative theta. So that equals this ratio. Or just say that tangent of negative theta, because once you take the inverse of this, it's just tangent of negative theta. So tangent of negative theta, we do know that tangent is odd function, so take out negative, so it got negative tangent of theta. So negative, negative, so we do have a positive ratio, so that's going to be 24 over 7. Okay, so the last one I would like to go over here would be the proving the identity. Okay, so proving the identity like this one here, so using that the difference of two squares, so cosine square of y minus sine square of y, and then cosine square of y plus sine square of y. So basically this part right here is 1, so cancel it out. This one you can distribute, or basically just the identity of double angles of cosine of 2y. And the other side right here, same thing, 1 minus sine square of 2y, it's just cosine of 2y. So prove. Okay, so let's do one problem with the graph. So this one, negative 3 cosine of x, we do know that cosine, it's an even function. So negative 3, but it's considered reflected. So normally we started out with the high peak right here, 3. But now due to the reflection, we goes back down here. So instead of going this way, bell curve, so this one is a normal bell curve. So it's not going to be inverted, it's going to be just like a normal bell curve. Okay, so going this way, one cycle. And then the rest of the graph here is just the continuation or the repetition. One cycle, bell curve. Which trig inverse shown below? So this one is looks like it's considered, well, this one it's by pi over 2 at 1. So most likely this one would be the inverse functions of sine. And then the vector, so dot product, so normally people doing that, it's like a times, well, this one is AB, this one is CD, so it's AC. Dot product, that means you're going to come up with the scalar, so it's A times C plus B times D. So multiply those numbers and then combine them. Vector, so C and S, so what's the angle between? So this one, besides doing the dot product of C and S, also you take the norm of C, and then the norm of S, and then you take the inverse of cosine of that ratio. So the way to find the norm is just the Pythagorean theorem. So this one is like negative 6 square plus 2 square, and the other one is negative 6 quantity square plus 3 square. So once you get the norm, which means the magnitude of the vector, so put it in. After you do the dot product, set up the ratio, and then take the inverse. So convert that from polar form to rectangular form. So R, it's always written as square root of x squared plus y squared, so that equals 11 times cosine of theta. And other things that it's better to multiply by r first, so 11 r cosine theta, so it's x squared plus y squared equals 11 times x. and then the rest of that is just doing the reciprocal, the opposite way. So this one would be r squared equals 5 times x. So x is just like r cosine of theta. Okay, so writing the corresponding rectangular equation, just similar to what we've been doing. Okay, so thank you for watching the video today. So I'll see you guys next time. Take care.